In this video, we're going to look at domain and range. Domain is a list of all the possible x values for a graph and a function, and the range is all the possible y values for a graph or a function. And notice the green arrow is referring to the x values on the x-axis, which is going left to right, while the range is referring to the values on the y-axis going up and down. So the first type of function we're going to look at is cube roots. So here we have 3 cube roots without an actual function, but the reason I didn't write you the function is because if we take a look, my domain, so all my possible x values, if I follow my graph left to right, there is no limit to what my domain can be. And when there is no limit to what my domain can be, when I am including all the x values, we call that the domain of all real numbers. And similarly, when we look at the range or all the possible y values, while it looks like my graphs are flattening out, they're still slowly decreasing towards negative infinity and increasing towards positive infinity, so the same thing is true for my range. And if we look at the other 2 graphs, we'll see that my x values are going to be all real numbers. In this example, just like my range is going to be all real numbers. And the same thing is true for this last one. So all cube root functions have domain and range of all real numbers. So my domain and range is the same for this one. It's the same for this one. It doesn't matter what my equation is for cube roots. It's going to be all real numbers for the domain and range. However, for square roots, and specifically we're going to look at negative square roots because the other video goes over a positive square root example. We'll start here with this first example of f of x equals negative square root of x minus 1 plus 2. And what this negative does is this negative creates the reflection reflection over the x-axis. So what that reflection creates my graph is it causes my graph to now go down. So now we can see that my graph is no longer going positive, it's going down. And when I say it's going down, that's going to affect what happens here with my range. So we'll go ahead and start with the range for this example. So my range, which refers to my y values, well, my range is going to be connected to this value right here of 2. But I notice that my value of 2 is actually the highest y value. My y values are going to start at 2 and go down. So they start at 2 and go down. So the range is y less than or equal to positive 2. My domain is going to start here at 1, and domain is connected to the x values. And it's going to start here at 1, and it's going to go in the positive direction. So it's going to go towards positive infinity. So x is going to be greater than or equal to 1. So again, my domain is going toward positive infinity, while my range was actually going down to negative infinity. So we say y is less than or equal to 2. So let's take a look at the second example. Again, notice we have this negative sign out in front, which causes it to be a reflection. And this plus 4 actually moves my graph to the left 4. So what I end up with is a point here at negative 4, 0. And a graph, it's going to look something like this. So this time we'll start with the domain. And again, we'll see that the domain is going to start here at negative 4. And it's going to head again towards positive infinity. How do I know? We'll follow the graph. It's heading towards positive infinity. So x is going to be greater than or equal to. And my range, which is going to start here at 0, is going to go down. Again, follow your graph. See that it's going down, and it's going down to negative infinity. So my range is going to be y less than or equal to 0. So whenever you're given an equation, graph it, use it, and trace it. Actually follow as x values go and as y values go to find your domain and range.